The question is it planning to not only probe these planets, but perhaps even release probes that will visit the Earth?
Something has already happened. Something that could reshape everything we believe about the most mysterious object currently moving through our solar system. We still don't know whether we're looking at nothing more than a strange interstellar rock, or the first real clue of advanced technology that didn't come from Earth. But now, after this moment, we may finally begin to get our answer. The only problem? We still won't be able to see what is happening in real time. On October 29th, ATLAS reached perihelion, the closest point in its path to our sun. At that moment, it passed just 203 million kilometers from the sun, around 1.4 astronomical units, slightly inside Mars's orbit. And according to Harvard astrophysicist Avi Loeb, this was what he called the decisive test, the moment of truth. This was the hottest and most extreme environment ATLAS will face during its entire passage through our solar system. At perihelion, ATLAS was struck with around 770 watts of solar energy per square meter, an intense blast of heat and radiation. For a normal comet, this is routine. When comets heat up, they undergo sublimation. The ice on their surface doesn't melt into liquid first. Instead, in the vacuum of space, it turns directly from solid to gas, forming the familiar glowing halo and trailing plume. But here's where things become extremely interesting. If ATLAS is a natural comet, loosely bound together like most icy bodies, this sudden heating should break it apart. It could fracture, crumble, and scatter into cloud-like fragments that rapidly evaporate. The sky would fill with a massive, dramatic plume, a kind of cosmic firework display. However, if ATLAS is not natural, if ATLAS is something constructed, if it has an engineered structure, internal support, or artificial shielding, then instead of breaking apart, it may maneuver. It might change direction. It could adjust its rotation. It might release smaller probes. We might detect anomalous heat signatures, structured light pulses, or controlled bursts of acceleration. But there's a problem. We still cannot observe any of this directly, because during perihelion, ATLAS was positioned behind the sun from Earth's perspective. Its behavior was completely hidden by solar glare, which leads to the unsettling question Avi Loeb raised in his recent paper. Was ATLAS's path intentionally chosen to ensure this crucial moment could not be seen? He calls this the Trojan horse scenario. A Trojan horse appears harmless on the outside, but something extraordinary may be hidden inside. Loeb warns that dismissing such a possibility simply because it feels uncomfortable would be a dangerous mistake. The people of Troy only realized the truth when it was too late. This is not science fiction speculation. Avi Loeb co-authored an official advisory document urging global policymakers to take seriously the possibility of a low-probability but high-impact black swan event involving an unusually massive interstellar object moving along the ecliptic plane, just like ATLAS. And yes, ATLAS reached perihelion just 2 days before Halloween. A comet wearing a costume, or a visitor revealing its true identity. We first detected ATLAS in July 2025 using the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a global network of automated telescopes in Hawaii, Chile, and South Africa. These observatories scan the sky constantly, searching for anything that moves. On July 1st, astronomers spotted a new object drifting across the star field. It was logged routinely, just another asteroid, until its speed was measured, and that changed everything. Earth travels at 30 km around the sun. Mercury travels at 48 km, but ATLAS was traveling at 58 km, and it was still far from the sun, just inside Jupiter's orbit. This speed meant one thing: ATLAS was not bound to the sun. Its trajectory was hyperbolic, meaning it came from the deep interstellar void and will leave the same way. This made ATLAS the third confirmed interstellar visitor in human history. The first was Oumuamua, long, thin, reflective, and extremely strange. The second was Comet Borisov, which behaved mostly like a normal comet, but ATLAS differs from both in 3 critical ways. Size: ATLAS may be over 5 kilometers wide, far larger than either visitor before. Speed: it travels nearly twice as fast. Origin direction: Oumuamua came from above the solar system's plane. ATLAS came from within the ecliptic plane, the same flat disk where all the planets orbit. This direction is highly unusual, almost as if Atlas approached along a designed trajectory, rather than by random chance. And now that perihelion has passed, either Atlas behaved like a natural comet and began breaking apart, or something else happened. Something we may not be ready for. Borisov did almost the same thing. It approached at a diagonal angle instead of straight down, but it still came from roughly the same region in the sky. Now, Atlas isn't a direct head-on approach either. It's entering from the side. But here's the part that has stunned astronomers. It's coming in almost perfectly aligned with the planets. Our solar system is shaped like a wide, thin disk of planets, moons, rocks, and dust, all orbiting the sun on what we call the ecliptic plane. Atlas is passing just 3 degrees off this exact plane. Out of all directions in three-dimensional space, it happened to arrive almost exactly within the same flattened disk where every major planet orbits. That is an extremely unlikely coincidence. Not impossible, but very rare. While Atlas was officially recorded on July 1st, astronomers later realized it had actually been seen earlier, on May 7, 2025, by the Transiting Exoplanet Survey satellite, or TESS. Based on early calculations, scientists predicted Atlas's brightness would increase by about 1.5 times between May and June. But the actual data showed a brightness increase of 5 times. That means Atlas suddenly began reflecting far more light than expected. 2. Things made this observation extremely strange. First, the polarization of the reflected light. Most space objects, asteroids, moons, even previous interstellar visitors, show positive polarization. Borisov was positive. Oumuamua was positive. Atlas is negative, and not just slightly. Atlas has the strongest negative polarization ever recorded for any object in space. Second, its coma, the glowing halo around it. Atlas formed a coma while it was still beyond Jupiter's orbit, over 5 astronomical units from the Sun. That's so cold that comets usually haven't started forming any gas cloud yet. They're still frozen solid at that distance, but Atlas wasn't frozen. It was already releasing gas, primarily carbon dioxide. The ratio of carbon dioxide to water vapor was roughly 8:1. This is basically the reverse of what we see in normal comets. Most comets are dominated by water ice, with smaller traces of CO2. If you've ever seen dry ice, you know what happens when CO2 ice is warmed. It sublimates instantly, creating a cloud of fog. That's exactly what Atlas was doing, but way out in deep space. This early coma happened because carbon dioxide sublimates at much lower temperatures than water ice. During the summer, astronomers detected nickel in Atlas's gas cloud, but no iron. That is very unusual. Nickel and iron are normally found together in planets, asteroids, comets, and meteorites. So if nickel appears without iron, scientists ask, where did the iron go? What process separated the metals? It's also strange to see any metals evaporating from an object still that far from the sun. The likely explanation is that the huge release of carbon dioxide was pulling nickel atoms out with it. Then, something else changed. In late September, iron suddenly appeared in the coma, and soon after, the nickel-to-iron ratio shifted towards something closer to normal. So Atlas is becoming more comet-like over time, but it's doing this in a very unusual sequence. On November 3rd, 2025, Atlas will pass just 97 million kilometers from Venus. At the same time, it will be within view of the JUICE mission heading toward Jupiter. On December 19th, 2025, 6 days before Christmas, Atlas will reach its closest approach to Earth at 267 million kilometers, assuming it continues on a purely gravitational path. Avi Loeb has openly asked, will Atlas release probes toward Earth like Christmas gifts for humanity? His team at the Galileo project is already studying atmospheric data from their observatories to detect any unusual activity. Then, on March 16, 2026, Atlas will pass 54 million kilometers from Jupiter, close enough for the Juno spacecraft to photograph it and check for any radio transmissions like a possible hot technological signature. This is why perihelion, the closest point to the sun, is so important. If Atlas is a natural comet, loosely held together, the intense 770 watts per square meter of solar heating should shatter it. It should break apart, and the fragments should evaporate rapidly, producing a dramatic and bright cometary plume. But if Atlas is artificial, possibly engineered, as suggested by its strange composition and metal ratios, it may maneuver, it may accelerate, it may deploy smaller probes, we may detect artificial light or waste heat from an engine, in Simple's words. This is the moment of truth, as Avi Loeb put it. In a blind date of interstellar proportions, we must observe our partner rather than be limited by the imagination of Hollywood screenwriters. Tomorrow, October 29th, is when Atlas reaches perihelion. Tomorrow may be the day the mask comes off, and the answer to one of humanity's oldest questions, are we alone? May finally begin.